as we look at number 23, you basically and I'm not going to draw them per se, exactly like they were, but you basically had something like this. Then you had the other one that goes right through the center. Okay. And then you had this one that went through here. Okay. Draw that one there a little. Okay. Basically, you had it similar to that. Okay. Now, the slopes, they were little. Basically, they were little. I've got my slope too large. But the slope, you were just measuring from one point to the next point. Okay? And the slope was really, it was 1 unit, actually it was 1 unit, and it was 2 units up. Okay? So the slope was 2, but where some of you, most of you got that, where some of you were messing up is where it crossed here. Okay, that's where you were messing up, was on your y-intercepts. Okay, and the y-intercepts were different. I believe the first one was 3. It was 3. This should be 0 because it crosses at the y-axis. So how do we know that? Well, you just go down the y-axis and see where the line crosses the y-axis. Wherever it crosses the y-axis is what your y-intercept is. Okay, and so you had, the first one was y equal 2x plus 3. Okay, the second one, since they're parallel, we know the slopes are the same, was 2x plus 0. Well, we don't need the 0. You don't need to have that. So it's just y equal 2x. And then the third one was y equal 2x plus negative 4, which is the same thing as y equal 2x minus 4. Okay, and those are your 3 equations in slope-intercept form. Now, remember, when you have a vertical line, okay, let's say that's our vertical line, and here's our X and Y axis. There's X, there's Y. So, where does this cross the Y axis? The blue line. 4. Crosses it 4. So the slope-intercept form of this is y equal 4. It's y equal 4 because there's no slope. Okay? The slope of a horizontal line is equal to 0. Remember, on a vertical line, there's no slope. Okay, and so you can't obviously put a vertical line in slope-intercept form. Okay, because there is no slope. All right, now, and obviously, if I have a vertical line, let's say I had a vertical line like this right here. Okay, does that vertical line ever cross the y-axis? No. So there's no way to put it in slope-intercept form. Okay, because it has no slope and it doesn't ever cross the y-axis.
Because the vertical line, put a vertical line over it, it would touch like every single point on it.
Right, so it can't be a function. Yeah. A vertical line can't be a function, obviously, because it'd fail the vertical line test. All right, let's look at number 30. Let's look at number 30. Number 30, it says in exercise 30 through 32, write a linear equation to model the situation. use unit analysis to check your model. Okay? Now, it says you borrow $40 from your sister. To repay the loan, you pay her $5 a week. Okay? So, you borrow $40 from your sister. To repay that loan, you pay her $5 a week, and they want a linear equation. Okay? A linear equation means that we need it in y equal something form. Okay? It's going to depend on the situation. You can't necessarily put it in the form that you can't put it necessarily in mx plus b form. It may have to be switched. Okay? So, if we let y equal what? What is y going to equal in this problem? Do what? Well, but can we have a 40 over there on the other side? Is it going to be in linear form if I do this? No. Slope intercept form? Like function form, linear form. You have two variables, a y and an x. Okay? But linear form means y equal, means this right here. That's linear form. Okay? Yep.
What's the y, x, and z little thing at the top under shape?
What?
Oh my goodness. It's by the...
That one?
I think they can see that.
Oh, what is that?
It's that.
That must be like a slope. Why didn't you just use that one time?
It's not a slope. It always goes through the zero.
It's a direct termination.
There you go. All right, now back to what we were discussing. All right. So if we let y equal the amount you owe on a given week. Okay? So if we want to know how much we owe on a given week, we're going to let y equal that. We're going to let x equal the number of weeks that it's going to take to pay back the loan. Okay? And we're paying back how much? Okay? So, in week 1 then, if we borrow $40 and in week 1, how much money are we going to owe after week 1? $35. What did you do? 40 minus 5, right? Okay. So, we don't know what our weeks are going to be yet. We just know that y is equal to the amount we borrowed minus 5 times the number of weeks. Okay? And so we can plug in any number for x and figure out how much we owe at that time. All right? So this would be it in linear form. No, that's what I was saying. You don't have to put it in mx plus b form. Okay? It can be in, as long as this would just, that would be your b, and that would be your slope. Okay, so -5 of your slope. So you could actually do a graph on this and do it, but they don't want you don't have to do all that. Okay, now it basically talks about unit analysis. Unit analysis would be this: dollars. This is dollars minus weeks over. Let's see. Okay? It'd be $1 per week or $5 per week times the number of weeks. Okay? And obviously, when you look at this, those cancel out. Okay? Leaving you with the dollars minus the dollars. You do not have to do this. Okay? Basically, unit analysis is what label you end up with. Okay? And so I'm not concerned. Y'all are pretty smart. You know how to do that. You know what obviously you know that it shouldn't be your dollars is what you're going to come up with and not weeks. Okay? So, tomorrow when you come in, we'll have homework. Okay? I'll give you that homework assignment tomorrow. But we're done for today. All right? Wednesday, no homework day.